Hello and welcome. For this video, we're going to go ahead and show you how to work the vector problems to find the resultant magnitude and vector C and vector D. So this is how we're going to work this here. What we're trying to do is we need to find the x and y components of these vectors. So it says that vector C is pulling with a force of 705 pounds. And that the angle of vector C right now is angle 1, which is 66 degrees. So I need to find the x component of C and the y component of C. And in order to find, basically we're just finding the sides of the triangle, so this is SOHCAHTOA. But in order to find the x component of C, that is the hypotenuse, which is 705 times the cosine of 66, and to find the y component of C, that would be CY, it's going to be 705 times the sine of 66. Now, if you want to go ahead and just set up a triangle and use SOHCAHTOA, you can do so, but the fast formulas are essentially the hypotenuse times the cosine for the x and the hypotenuse times the sine for the y. We're going to go ahead and do the same thing for vector D. Notice that vector C in the y direction is a positive number, and in the x direction it's a positive number. So we're going to leave those as positive, but if I go to vector D and I draw it over here, if this is vector D has magnitude 1105 and its angle is 25 degrees, but notice that its x component and its y component are both negative. So D in the x direction is going to be 1105 times the cosine of 25, but this is going to be a negative value. It's not going to show us a negative on our calculator. We have to see that that is x in our negative direction there, and y is also in a negative direction. So we have 1105 times, times the sine of 25 degrees, and that will put a negative there. Let's go ahead and take a peek at what those values are. Put those in my calculator. Make sure that you have values that your calculator is in degree mode. So I'm getting roughly 286.75. $644.05, 1001.47, and 446.99. 466.99. Okay, so now that we have these values here, essentially it's saying that we have a bunch of different vectors pulling in these directions. So we're adding up the x's, and so when we add up this x and this x, right, I have the resultant vector. We'll call that r of x, and the resultant vector in the x direction is negative 714.72, and the resultant vector in the y direction is going to be these summed up. So 644.05 minus 66.99, and we get 177.06. So if I have to draw this vector, I'm going in a negative x direction and a positive y direction. So really what this is being pulled like, I'm going in a negative x direction and a positive y. And so what's happening here, and I'll draw it to the other side, is I'm getting a resultant vector with these two magnitudes pulling, these two vectors pulling at those forces. It would be as if someone were just pulling with a y directional force of 177.06 in the positive direction, and we had an x direction pulling in negative 714.72. Now we could technically find the angle for this to really see what that magnitude and direction, or the direction of the vector, is, but all I'm interested in is the magnitude, and the magnitude is located on the hypotenuse. This is the magnitude of that resultant vector. That's the magnitude of D. And so how do I find that if I have a right triangle? Well, Pythagorean theorem, right? So MD squared is going to equal 177.06 squared plus 17.72 squared, right? And then we can take the square root. So when we find that value there, I'm getting 736.325. And that should be the magnitude of the resultant vector. And that is how we find it. You have to make sure that you're looking at the directions of where the vector is going. We had a negative x direction for vector D and a negative y. So that's why we put minus signs on these. And then we just sum those together to find the total magnitude. We create the new vector, the resultant vector, in whatever direction is that. So a negative positive, if we think of a coordinate plane, that's what's happening. I went a negative and then a positive. And then we just drew in our vector, resultant vector. Hopefully that's helpful, and you please use this video to help you with these practice problems in the future.